One of the mysteries of Britain's ancient Stonehenge.
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 For 200 years, scientists have been excavating, debating, and theorizing about Stonehenge, and for 200 years they got it wrong. Not because they were not smart, because the truth was physically invisible, buried under the ground, hidden inside the stones, encoded in frequencies the human ear cannot detect. Until now. In 2024, I was given the most complete 3D scan of Stonehenge ever created. Every surface, every tool mark, every inch of soil beneath it, and asked one simple question. What is this place really? What it found has left researchers stunned. The AI identified stoneworking techniques that do not match any known Neolithic method. It found acoustic engineering so precise, targeting a specific sound frequency, that it should not exist for another 2,000 years. It found mathematical ratios buried in the layout that predate their supposed invention by 2 millennia. And it found something beneath the ground that changes the entire picture of what Stonehenge even is. The data is real, the measurements are verified, and what they reveal is this. The people who built Stonehenge were not primitive. They were extraordinary. And somehow we forgot. This is what the AI found inside Stonehenge. Stonehenge sits on Salisbury Plain in southern England, about 88 miles southwest of London. Construction began around 3000 BCE and continued in phases for roughly 1,000 years, meaning it was already ancient when the Roman Empire rose to power. The outer ring is made of massive sarsen sandstone blocks, some standing nearly 30 feet tall, each weighing up to 25 tons, quarried about 25 miles north in the Marlborough Downs. Inside that ring, smaller bluestones, transported an extraordinary 150 miles from the Preseli Hills in Wales. No metal tools, no wheels, no written language. The traditional explanation has always been community effort. Thousands of Neolithic farmers using antler picks, ropes, and log rollers, moving stones across the landscape over generations, driven by ritual or religious motivation. That explanation is not entirely wrong, but according to the AI analysis, it leaves out almost everything that actually matters. Because when researchers stopped asking how ancient people could have done this and let the data answer for itself, the picture that emerged was radically different from anything in the textbooks. A joint British-American research team built the most comprehensive digital model of Stonehenge ever created. They used ground-penetrating radar to see below the surface, aerial LiDAR to map the surrounding landscape, photogrammetry drones to capture thousands of overlapping high-resolution images, and 3D laser scanners precise enough to record surface details down to fractions of a millimeter. The result was a complete digital twin. Not just the standing stones, but fallen lintels, buried remnants, and the terrain for miles in every direction. Then they fed all of it into advanced neural networks trained on ancient construction, acoustic engineering, and structural geometry. The first thing the AI flagged was the surface of the stones themselves. Under microscopic analysis, it detected 5 distinct stoneworking techniques. The first was expected: pecking and grinding with stone tools, consistent with Neolithic methods found across prehistoric Britain. Unremarkable. The second technique was different. Around the lintels and the tongue-and-groove joints, where the horizontal stones lock onto the uprights, the AI found shaping of unusual precision. Some curved surfaces showed less than 2 millimeters of deviation across a span of 2 meters. That is the width of a pencil line, maintained across a 6-foot stretch of hand-shaped stone. Dr. David Nash of the University of Brighton noted that the uniformity exceeds what traditional percussion and grinding methods would typically produce. And when the AI compared these marks against more than 50,000 documented Neolithic stoneworking examples from across Europe, it found 0 matches. Not one comparable technique from the same era anywhere. Someone shaped these stones in a way we cannot explain, and that is before we get to what they were shaped to do. Here is something most people have never considered about Stonehenge, what it sounded like inside. With a full 3D model of the complete monument, the AI was able to simulate the acoustic behavior of the space as it existed 4,500 years ago, when every stone was standing, when the circle was intact. What it found has a name: constructive interference. This is when sound waves bounce off surfaces and overlap in ways that amplify certain frequencies, rather than cancel them out. It is the same principle that makes a concert hall sound better than a warehouse, even if both are the same size. According to the simulation, Stonehenge's specific spacing and stone geometry created amplification in a narrow frequency band between 95 and 120 Hz. That is the exact range of a deep male voice or a large ceremonial drum. In practical terms, if you stood inside a complete Stonehenge and chanted or drummed at those frequencies, the sound would not just echo. It would grow. It would resonate. It would feel like the entire structure was vibrating with you. Dr. Rupert Till of the University of Huddersfield, who has spent years studying acoustic properties of ancient sites, described the effect as deliberately engineered. Here is the detail that makes it undeniable. The AI calculated that moving even a single sarsen stone by just 1 meter significantly disrupted the entire interference pattern. The acoustic effect only works if every stone is in precisely the right position. The system estimated the probability of this level of acoustic precision occurring by chance in a randomly arranged stone circle, less than 1 in 10,000. Formal acoustic theory would not appear in human history until ancient Greece, nearly 2,000 years after Stonehenge was built. Yet the data says the builders understood it, measured it, and encoded it in 25-ton stones. While mapping the exact geometry of the monument, the neural networks began flagging something in the layout that no one had formally identified before. Repeated right triangle ratios of 3 to 4 to 5, the proportions of the Pythagorean theorem. The Pythagorean theorem is attributed to ancient Greece, around 500 BCE. Stonehenge was built around 2500 BCE, 2,000 years earlier. The AI did not find one instance of this ratio. It found at least 7, in the spacing of the stone circles, in the geometric relationships between the Aubrey holes and the sarsen ring, and in the rectangular arrangement of the 4 station stones. It also analyzed the sarsen circle's proportions, and found a diameter to circumference ratio of approximately 3.14 to 1, within 99.7% of the true value of pi. Ancient Egyptian calculations are typically cited at 3.16, Babylonian approximations at 3.125. Whoever built Stonehenge was more accurate than both, roughly 1,000 years before either civilization recorded their calculations. Mainstream archaeologists make a fair point. Practical geometry can emerge naturally from builders using ropes and stakes. You do not need formal mathematics to produce right angles. That is worth acknowledging. But 7 separate instances of the same ratio, combined with a near-perfect approximation of pi, embedded in a monument also optimized for acoustic performance and astronomical alignment. At some point, the pattern becomes harder to dismiss than to accept. The AI also reconstructed the night sky above Salisbury Plain in 2500 BCE and compared the positions of celestial objects against the monument's precise orientation. The summer solstice alignment, the sun rising over the heel stone, has been documented for centuries. That was not new. What the model revealed beyond that was the encoding of the 18.6-year lunar cycle, the time it takes for the moon's maximum declination to complete a full oscillation. This is not a pattern visible to casual observation. To recognize it, you need to track the moon's extreme rising and setting points consistently over nearly 2 decades. According to the analysis, the 4 station stones arranged in a rectangle around the central circle correspond closely to these lunar extremes. If accurate, encoding that alignment required not just astronomical knowledge, but institutional memory, observations passed down across multiple generations with the discipline of a sustained scientific program. These were not people making casual observations. The data describes a civilization conducting systematic, long-term astronomical research and building the results into stone. Perhaps the most unsettling finding was not what the AI found in the stones. It was what it found across time. By analyzing tool marks, erosion patterns, carving styles, and weathering across different construction phases, the AI was able to sequence the building stages of Stonehenge chronologically. What it found reversed every assumption about how ancient skill develops. The earliest phase, around 2500 BCE, shows the highest precision, the tightest joints, the most refined shaping, the most accurate alignments. The acoustic optimization and embedded mathematical ratios belong to this phase. Later phases, stretching toward 1600 BCE, show declining quality. Looser joints, less consistent tool marks, coarser shaping, less accurate alignments. By the final phase of construction, the craftsmanship is noticeably inferior to the very first. In Egypt, pyramid construction improved over centuries. In Greece, architecture grew more sophisticated generation by generation. Civilizations typically accumulate knowledge. At Stonehenge, the evidence points in the other direction. The peak was the beginning. One interpretation is difficult to avoid. The original builders possessed specialized knowledge that later generations could not fully replicate. The techniques may have been preserved in ritual form, passed down without complete understanding, until eventually the ability to execute them was simply lost. We have a word for that, we call it forgotten knowledge, and Stonehenge may be its most spectacular monument. Ground-penetrating radar and LiDAR scans fed into the neural networks revealed something even more dramatic. Stonehenge is not a monument. It is the center of one. The AI flagged at least 200 additional post holes, pits, and buried features arranged in geometric patterns across the surrounding landscape, patterns that had never been recognized as a unified design. 17 previously unknown ritual monuments were identified in the wider area. Evidence of a massive house of the dead, a superhenge at nearby Durrington walls that may once have been flanked by up to 60 massive timber or stone columns. And then there is the landscape itself. When acoustic modeling of the Sarsen Circle was overlaid with topographic LiDAR data, researchers noticed that certain ridges and shallow valleys surrounding the monument appear partially shaped rather than entirely natural. Some embankments show signs of deliberate, large-scale earth movement. According to the simulation, these raised and lowered sections of terrain would channel sound from the surrounding landscape directly toward the monument, so that drumming or chanting from outside the circle would be funneled inward, then amplified by the stones. The AI estimated that shaping this landscape would have required moving hundreds of thousands of cubic meters of earth using only antler picks and woven baskets. The work may have taken decades, and it would have happened before the first stone was ever raised. Only about 5% of the full Stonehenge site has ever been excavated. What the AI has mapped suggests the remaining 95% contains structures, arrangements, and perhaps answers we have not yet imagined. Around the world, in the same prehistoric era, other cultures were doing something remarkably similar. Göbekli Tepe in Turkey, built 6,000 years before Stonehenge, contains massive carved pillars aligned with celestial events. Newgrange in Ireland is precisely aligned with the winter solstice and carries striking acoustic properties of its own. The Carnac stones in France stretch for miles in complex geometric arrangements. The Nebra sky disk from Germany encodes solar and lunar cycles. Across Neolithic Europe, large stone monuments repeatedly demonstrate the same obsessions: the sky, sound, geometry, and scale. Not in one place. Everywhere, independently, at roughly the same time. Which means the question the AI has opened is not just about Stonehenge, it is about us. About the full range of what human beings were capable of before the written record began. About how much knowledge was accumulated and how much was lost. The data from Stonehenge suggests that the builders were not primitive people doing their best. They were sophisticated observers, engineers and mathematicians operating with a level of intentionality we are only now beginning to measure. And maybe that is the most shocking result of all. Not that ancient people built something extraordinary, but that for 200 years we looked directly at the evidence of what they knew and did not see it. The AI saw it. In under a year. In a data set we already had. That should make us wonder what else we are missing. If this changed how you think about ancient history, hit like and subscribe. There is more where this came from.